Lake levels are predicted to fluctuate markedly, while sea level is projected to rise at increasing rates. Major tourism impacts in the Great Lake region are year-round, while climate impacts in New Jersey are projected more likely in the summer. But there are also a great many similarities. Air and water temperatures are getting warmer. Total precipitation is increasing, and heavy precipitation events are becoming ever more frequent. Winter ice cover is more variable, becoming less likely and less extensive. Water quality is projected to worsen due to nutrient inputs and cause increasing hypoxia and algal blooms. Southern plant and wildlife species are becoming increasingly common. Droughts are increasing, which is likely to affect water supplies. And there are many other similarities, especially with regard to impacts on economic and human health. In short, there is a lot to be concerned about. Over the past several months, I have learned quite a bit about my new home state, and specifically about the Barnegat Bay, the crown jewel of the Jersey Shore, with its unique and distinctive landscapes, pygmy forests that thrive among fire-adapted pine barrens, stands of Atlantic white cedar bordering freshwater marshes and streams, intertidal coastal wetlands, and beds of submerged vegetation that serve as nurseries for fish and other wildlife. For more than a century, people have been flocking here to enjoy sailing, fishing, and other activities. However, over the past 50 years, the growing population among the Barnegat shores has led to an increase in nutrient pollution and contributed to issues such as deteriorating water quality, an increase in harmful bacteria, and a decline in critical species. As leaders of this important stakeholder group, our efforts and support are vital to ensure the restoration and long-term protection of the Bay and its entire watershed. The Barnegat Bay Partnership, housed here at Ocean County College, one of 28 EPA-funded national estuary programs, has been one of the many partners in this collaboration to protect and restore the Bay. I'd like to recognize and thank the director and the entire staff of the partnership for their many efforts. Dr. Hales, will you and your staff stand to be recognized? They work tirelessly to monitor environmental conditions in the Bay year-round, risking malicious attack by mosquitoes, greenheads, stinging bay nettle, all to ensure the Bay management decisions are based on the best available science. Barnegat Bay Partnership's 2021 Comprehensive Conservation and Management Plan and the 2021 State of the Bay Report represent the consensus of the BBP's many partners and their extensive interactions with the public. Today represents a momentous occasion, the announcement of a nitrogen water quality standard for the Barnegat Bay, achieved through the establishment of a total maximum daily load, a metric which identifies the nitrogen load reductions needed to protect the Bay's aquatic life and human uses such as fishing and swimming. This standard represents an important milestone, reflecting more than a decade of work and many millions of dollars. As the newest member of the Barnegat Bay Partnership's Policy Committee, which reviews and approves the partnership's work plan and budget, I'd like to personally thank representatives of the other policy committee organizations joining us today. From the United States EPA, Barbara Spinweber; from the New Jersey Department of Environmental Protection, Kim Seno, Lynette Lurig, Bob Schuster, and Helen Pang; from the Ocean County Board of Commissioners, Commissioner Joseph Akari and Mr. Tony Agliata; from the BBP citizen representatives, George Murniak and Murray Rosenberg; and on behalf of the entire Ocean County College community, I thank all of you for joining us and for your ongoing efforts and dedication to this work. I'd now like to reintroduce Dr. Stan Hales, Director of the BBP, for a special recognition of those who have been supporting these efforts.
Thank you, Dr. Monaco. As she just mentioned, there have been a lot of people who've supported the partnership's efforts for a long time. And so what I'd like to do is talk briefly about the two individuals, Commissioner Joseph Vicari and longtime OCC President Dr. John Larson. These two people have supported the program literally since its inception, more than 22 years in the case of Commissioner Vicari and 17 years in the case of Dr. Larson. To put that in perspective, there have been, I think, 7 DEP commissioners, 6 EPA administrators, and at least 3 previous directors. The program moved from the state of New Jersey to Ocean County and then here to the college. And during that time, both of these individuals have been completely supportive of our efforts. With regard to Commissioner Vicari, as I said, he's been here during a period of tremendous change over the entire course of the program. And to give you a brief idea, when I started at the program office, there were 2 staff, and now something like 14, maybe even a few more if you include all the temps who are in various stages of hiring at this point in time. I went back through some of my notes to look at all of the things that Commissioner Vicari and I have spoken about over the years. Water supplies, open space. He's brought in representatives from a number of departments at the county. Off the top of my head, that would include planning and solid waste, roads and engineering, the administration, parks and recreation, tourism and business development, and the health department all have provided representatives to the partnership in support of our efforts. Over all of those 21 years, there's one theme regarding Commissioner Vicari's support, and it's something he even mentioned to me briefly in our conversation this morning. He said, you know, open space is important, and you got to keep an eye on the kids and, by extension, their grandparents. And everybody knows, you know, parents, you know, sometimes have negative impacts on their kids. All you have to do is ask the kids, but nobody ever messes up their grandchildren. So, Commissioner, I want to thank you for that. So if you could come up here for just a minute, I'd like to give you a small token of our appreciation. And Dr. Larson, you're next. Let's get this into the light of day over here so everyone can see. We've got a little acknowledgement. So thank you very much. So,
this came as a shocking surprise. As you know, I've been an educator for almost 50 years in Ocean County. But there's a little bit more why it's so important to me. I came from an area, an urban area, the poorest place in the state of New Jersey, Jersey City, Hudson County. And that's why I have a deep appreciation for what you have done, working with the state, federal government, local, and of course, the county college with, and a good friend of ours, Dr. John Larson. And I really feel a special place in my heart because I remember when I first came to Ocean County, I was an educator. And one of the reasons why I came, it was the environment and education, and one key word, opportunity. The opportunity that we give to every single person that lives in Ocean County, no matter what your age. And as an educator, when I got out of St. Peter's University in Jersey City, I remember going down to the waterways. It was polluted. Colgate-Palmolive let all the pollution out there. There was coal in the Hudson River. Now it's one of the cleanest. You know why? The people spoke up. And one of the first things I did when I came to Ocean County, working as a teacher in a brick board of education, was one thing I realized it from my students. They would go outside, they were hunters. They liked the environment. They were second and third generation people. And I said to myself, I said, you know, I saw all this building taking place in Brick Township in Thomasville, in the northern part of the county. I said, you know something? I have an obligation in my heart to give this not only to my children, at that time I didn't have children, I wasn't married, to my children's children. And that's what today is all about. Today is all about making sure the great things that we have today go to our children's children. Now, I love the tourism. I'm director of tourism is here today also, $7 billion a year. Number 3 in the state. People work. They go to work every single day. But it's not just for tourism. It's the right thing to do. Going back when there were 27 national estuaries in the United States of America, we worked real hard to make it. The 28th was Barnegat Bay. Barnegat Bay. And we said, what we have to do is to make sure we pass that idea to other people, to other generations. And that's why I'm so proud. As you know, I'm retiring after 42 years. And there were a lot of people that I have to be thankful for. Stan Hales, our director for many years, second one, we worked very close. Dr. John Larson, when we had an issue, we had to put the building someplace else. The county couldn't do anything. The first thing Dr. Larson said, we will help, because we want to be an educational community. We want to work with the college and the environment and Barnegat Bay. And it helps the students, it helps everyone. And many times people, I'm not going to say thank you, Dr. Larson, for what you've done, but one thing I really have to acknowledge, and I didn't speak to you before this publicly, is we always had his telephone number. Call him up, come to his office, and it was always equal among equals, not only with me and Dr. Larson, but the people, the professors and everything else, and that's very important. With this program, the reason why it's, I think, nationally known is information. Getting information, making sure it's transparent, but it's collaboration, sharing information, sharing ideas. And one thing I learned from Ocean County College, I learned something every day as an educator, is everyone can think differently. That's what's so great about America. You can be different than mine. We have a different focus, but we all have one end. We have one aim, and that is to preserve Barnegat Bay right now. Nitrogen, one of the first stories I have to tell you, I sat down when I was on a committee, and I had a desire to improve Barnegat Bay. Eutrophication. I said, I didn't know what that word was. And I didn't know, and I'm an educator. And what do you do when you're an educator? You ask a question. And you know what someone did? I didn't even know their name. I don't even know who the person is today. She explained to me about nitrogen, about oxygen in the water. And I wasn't embarrassed. You know, people today are afraid to ask a question. That's what this country needs, more people. Question to question. Question not only authority, but we have to question things more so. And with Barnegat Bay, I'll tell you right now, and even with Tony Agliana, no one asks more questions than me. Because I grew up in an era that you questioned everything, which is a good thing. So I would say the best thing to do right now is question everything, because we do the right thing. It's based on facts. It's based on what's good for Ocean County, but it's also based for New Jersey, and it's a national estuary. People come from all over the area, not just New Jersey, for Barnegat Bay. We have to do something. Our mission, again, preserve it for future generations. So I thank you for this award. And these are my favorite students. As he said before, I was the superintendent of Berkeley Township when I retired. And I wanted to do something no one did in the state of New Jersey. And you know what I did? I only mention this to certain people, my friends. I worked for a year and a half. And I said, get all the money, $250,000, give it back to the students. Give it back to the people that you see in this picture. Give it back to special needs kids. Give back $250,000, and all my salary at that time, including expenses and all, went back to these kids. I don't even know what year they came from or whatever the case may be. So again, I'm really privileged. I'm greatly honored, and it means a great deal to me to realize the impact is not only making a difference, being part of that difference, being part of the difference. And I don't know who they are in the pictures in here, but I know one thing. It's not just Joe Vicari. It's not Dr. Larson or Stan Hale. It's everybody that's in this room. So thank you very much. God bless you. I appreciate the great honor and this award. Yeah, that's all right. My good son. Thank you.
Thank you, Commissioner Vicari. Dr. Larson, I don't know where to begin. You and I attended our first policy committee meeting together for the first time. I have worked with, I think, 5 vice presidents under you here at the college. Over that entire period of time, the program office has changed tremendously. You have long been our most ardent supporter. To this day, the college doesn't take a dime out of our grant funds. We've had a number of incredible conversations about all sorts of things that I never would have imagined when I first came here. A few that I'm not surprised we had conversations about. CAFRA regulations, wetland regulations, swamp pink, and a number of other T&E species that are here on campus. The evolution of education, especially the college landscape. We talked about Jared Diamond's perspectives on environmental influences on human ecology. That surprised me. And I appreciate our conversations about water in all its forms, including various distillations of other liquids. So we've had lots of good times and lots of interesting conversations. I know that retirement marks a profound change in many things. We've often talked about your family. You've got family in New Hampshire and Georgia, where I have a lot of experience. I know you'll be traveling to both those areas extensively in the not too distant future. I know you've also a fondness for traveling to other parts of the world. One of the things that we want to make sure of, all of us here, is that you always have something to guide you home. So a photograph from one of your friends. So
So we're going to take a picture?
yeah, we'll take a picture if you like. Remember, I say some remarks. That's welcome.
Well, thank you very much, Stan. It's a tremendous honor, and I am very grateful. I have enjoyed immensely my participation in the policy committee. And as Stan indicated, he is the second executive director of the Barnegat Bay Partnership after Bob Scrow. And when we first got to know the Barnegat Bay Partnership, Bob Scrow was the leader, and that's when they decided to come on out here. And so the hiring of Stan Hales has made just an enormous difference in the progress that has been made by the partnership members, by the activities that have gone on throughout the county, and more importantly, even to us here at the college, right here on the college campus, because we agreed from day one when we first met that we would make the college campus a laboratory for the Barnegat Bay Partnership, and they have done a marvelous job helping the college to essentially be good stewards of the property. I also want to just say a word or two about my sidekick over here. The longest serving freeholder commissioner in the history of Ocean County, and maybe the history of all of the 18 community colleges. Is that correct, Joe? Yeah, 42 years, and that's no mean accomplishment. Let me tell you, that is remarkable, and he's done a fabulous job. We would not have the Performing Arts Academy on this campus if it were not for Joe Vicari. And he's been a marvelous force for good. He's an educator and somebody who understands the issues that colleges and K-12 world folks face when they try to address the kinds of issues that we have been doing with the Barnegat Bay Partnership. And I would be remiss, and I know Joe appreciates this, that both of us had a very, very good friend in Mr. John Bartlett. There's a building named after John here on the campus because he did so much good for this college. He single-handedly arranged for the college to achieve a AAA bond rating, which he worked at diligently for years and years and years. And I don't know if there is another county in New Jersey that has a AAA bond rating, possibly, but if so, it's a rarity. Unfortunately, a lot of places in New Jersey spend too much money and they don't put enough away for the rainy day. But John Bartlett was somebody who absolutely made sure that the finances of this county were going to make it a shining light for the proper way to handle economics and finance for a public entity. So between Joe Vicari and John Bartlett, I think we had two of the best freeholders and commissioners in the history of the institution. And we should all be very proud of the both of them. So Joe, congratulations to you and thank you for your service over the years. I want to say a few words about Stan Hales because Stan has made this program. He's only the second executive director in the history of the program here in the Barnegat Bay estuarine region. And he's done more good for this county environmentally than along with all of the partners, and we are most appreciative of all of them, the EPA, the DEP, and all of the other partner organizations who make up the Barnegat Bay Partnership. We are grateful to all of the contributors for all they have done to make this county and the preservation of the Barnegat Bay number one in importance. It is a money printing press for this county. The Bay is an asset that has been a draw for all kinds of people who want to come here. And it's one of the reasons that for years and years, this has been the fastest growing county in New Jersey. I think now it's slowed down a little bit, but hopefully one of these fine days, it'll begin to grow again. As long as we don't give up on building a few buildings. Inside baseball. I want to just also express my appreciation to all of the folks who are here today, because each one of you have made valuable contributions to public fisheries. You've been outspoken in your point of view regarding the damage that some of the wind power activities and off the shore of New Jersey have had on the marine life, and I think been critical factors in the bay reclamation for clams and oysters and preserving upwellers and doing all kinds of things that just are marvelous for the marine life in the bay. And one of the big issues now that we're facing is soil erosion, which is essentially getting far too much silt into the bay and is part of the problem of eutrophication. So we're very proud of the achievements of the entire Barnegat Bay program. The staff has done a marvelous job, and the leadership we've had from Stan Hills has been exceptional. So, Stan, thank you so much for what you've done. Thank you to each and one of you out there who have been involved in achieving so many of these accomplishments. And all we can say is you will be our friend and our partner here on the campus, I hope, forever and ever. Thank you very much. Now we're going to pick. Thank you. The Barnegat light. Beautiful. Yep. Thanks.
Thank you again, Dr. Larson. It's my pleasure to kick off this momentous day, introducing Kim Seno, who's the Bureau Chief of the Bureau Environmental Analysis and Restoration. So Kim, you ready to go?
Good morning. Thank you, President Monaco and the Ocean County College for hosting this information session today with all of you. My name, as Stan says, Kimberly Seno with the New Jersey Department of Environmental Protection, and specifically the Division of Water Monitoring and Standards. And we have the responsibilities for doing all of the state's monitoring for our waters. We develop the groundwater and surface water quality standards. We have the Clean Shores program and many other things that you'll hear about later today. I'd like to introduce those in here in person today from the department. We have Vic Peretti, our director, Yazo Sivaganish, Helen Pang, Crystal Corello, Ryan Hughes, Lynette Lurig, and Bob Schuster. So thank you for them attending in person. And I'll just have some quick housekeeping and logistics. We have 102 people registered for today's session. 36 people in person and the rest online. So thank you for joining us. Those that are in person, we did have a sign-in sheet and a hard copy of the agenda. So if you didn't get that when you came in, please sign in and grab a copy of the agenda. Those of you online, if you'd be so kind as to please in the chat, put your name in the chat and your organization, because we would like to keep track of those that attended today's session. We are recording today's session as well, so that will be available for preview for those that want to have follow-up and remember all of the presentations that we covered today. We will have a break after a couple of presentations, and everything, like I said, will be recorded and will be there to follow up on. So we've pulled together a work group of people to put today's session together. That included Dr. Stan Hales of the Barnegat Bay Partnership, Britta Forsberg from Save Barnegat Bay, Tony Agliata from the Ocean County Planning Department, and Dr. Jacqueline Rhodes from the Pinelands Preservation Alliance to put this first of 3 sessions that we're going to have on the Barnegat Bay. We're here today to provide you on the department's Barnegat Bay initiative that was started back in 2010 when the department committed to adopt more rigorous water quality standards. At that time, the department held a series of listening and information sessions, which resulted in the Barnegat Bay 10-point plan, and based on the stressors and ecological concerns raised by the stakeholders. To support the development of more rigorous water quality standards, the department began a multi-year monitoring effort to serve as the basis for water quality models developed for Barnegat Bay by the United States Geological Survey. And you'll hear more about that this morning from Helen Pang. We've developed a site-specific nitrogen water quality standard for Barnegat Bay and are developing a pollution budget, which is known as a total maximum daily load, or TMDL for short. And that will use the model developed by USGS to calculate loading reductions needed throughout the bay and the watershed to attain the water quality standard. Improvements to water quality in the bay happen at the local level, and that's why we'd like you to ask questions during today's presentation and to give your feedback so that we can better inform in our follow-up sessions. So for those of you that are online, please type your questions into the chat. We will be monitoring that, and then we will be reading your questions out loud. And for those of you that are in person today, we will also be taking questions from you. Our first presenter will be Lynette Lurig, and she's going to walk us through the 10-point plan, just to remind us of where we got this started. And then we will hear from Helen Pang to adopt more rigorous water quality standards. And she'll go into more detail about the monitoring, modeling, and the total nitrogen target that was calculated. And then we anticipate having a break for a few moments, and then we will start back up again with some specifics of projects that are already ongoing in the bay. So I will then turn it over so we can start the next presentation, and happy to introduce Lynette Lurig, who I think needs no introduction as she is a familiar face in Barnegat Bay.
Thank you, everyone. As Kim said, my name is Lynette Lurig, and I work in the Division of Watershed and Land Management. And I want to bring everyone back to early 2010. Actually, in 2010, I didn't need these, but I do now. The just elected New Jersey governor expressed interest in learning more about Barnegat Bay. The DEP was tasked with heading up this initiative. DEP created an internal team to work with external partners to develop a plan of action. Stakeholder meetings were held throughout 2010. Some of you here virtually and in person were probably at several of those meetings. And on December 9th, 2010, the 10-point plan of action to address the short-term and long-term ecological health of Barnegat Bay was announced. That's what we lovingly call the 10-point plan now, for short. These are the original 10 points that were developed through this group of scientists and stakeholders. I will highlight some of these 10 points now. Action item number 1, close Oyster Creek Nuclear Power Plant. Oyster Creek stopped generating power in 2018. That is 1 year earlier than outlined in the plan. DEP has conducted scientific studies to determine the effects of the determination of this plant, both pre and post studies. Since the plant stopped operating 1 year ahead of schedule, the pre-testing was cut short, but we do have results of these studies both pre and post. Action item 2, fund stormwater runoff mitigation projects. Between 2012 and 2023, the Water Bank, what used to be called EIT, the Environmental Infrastructure Trust, has funded 159 projects in Barnegat Bay communities at the cost of $354 million. Projects such as drainage improvements, sanitary sewer lining and replacements, salt domes, and the purchase of street sweepers were funded. Additionally, 319 Clean Water grants provide funding to help with stormwater. Number 3, reduce nutrient content from fertilizer. In 2013, New Jersey implemented the strongest fertilizer rule in the nation at that time. All turf fertilizer products sold in New Jersey contain 0 phosphorus and at least 20% slow-release nitrogen. DEP is in the process of developing a study to determine if there are any impacts this fertilizer law has had in our basin. Action item number 5, acquire land in the watershed. This is an extremely important action for Barnegat Bay. I want to be honest with you, I don't have current accurate numbers from DEP, but I do know our Green Acres program has permanently preserved thousands of acres in the watershed over the last decade. And most importantly, Ocean County continues to do outstanding work in acquiring and preserving land in our watershed. Action item 8, educate the public. A very big thank you to Barnegat Bay Partnership, specifically Karen Walzer and Bailey Sanders, for taking the lead on the 2 main outreach initiatives for this action item, which are the Barnegat Bay Blitz and the Rain Barrel Challenge. We continue to have a watershed-wide cleanup activity on every Earth Week. New Jersey DEP is still involved, however, Barnegat Bay Partnership is now the lead. Our 16th Barnegat Bay Partnership, Barnegat Bay Blitz, is next April. And 319 water grants continue to fund outreach in the watershed, including our most recent grants, the Bay Friendly Stewardship Program, which Barnegat Bay Partnership heads, and the Municipal Stormwater Outreach with Save Barnegat Bay. Number 9 is produce more comprehensive research. DEP funded many research projects with an extensive list of experts. Some of the most important studies that help support the TMDL model development include our bathymetry survey. This had not been done since the 1940s, and it's unique because we have both pre- and post-Superstorm Sandy data. We have an air monitoring station within the watershed and shallow water sediment resuspension and light attenuation projects. All 20 of these projects we funded are included in a special issue of the Journal of Coastal Research. Some of the important things we learned and confirmed: sea nettle larval DNA is found throughout the bay, and life cycle information can aid in population management of the sea nettle. Wetlands can remove between 54 and 85% of nutrients entering the bay. Sedge Island Marine Conservation Zone acts as a refuge for crabs and clams. Locations of hotspots of boat scoring exist in the bay, and we see a negative response in sensitive organisms to an increase in total nitrogen, which can help set the TMDL target. There are copies of this journal out front, and if we need any more, I could get them for you, a hard copy of them. Action item 10, reduce watercraft impact. There are very few regulations on the water, especially ones that protect the environment. So the few we do have are very important. Watercraft have the ability to severely damage resources of the bay. Research from action item number 9 show how vital the Sedge Island Marine Conservation Zone is to the health of Barnegat Bay. This is the only place in the bay that restricts personal watercraft and commercial activity. Through a 319 grant, we are participating with Ocean County Sheriff to assist in educating the public, specifically personal watercraft users, with the special attention on Sedge Island Marine Conservation Zone, which is right off of Island Beach State Park. Hopefully, you've all been there. And then, action item 7, adopt more rigorous water quality standards. The purpose of the Barnegat Bay Water Quality Study and Monitoring are to determine the locations and extent of water quality impairments, identify numeric criteria or loading targets for nutrients to guide restoration endpoints, and most importantly, calibrate and validate modeling tools that can be used to direct water quality restoration and TMDL development for the bay. And Helen Pang from the Bureau of Environmental Assessment and Restoration is here now to explain the monitoring, modeling, and total nitrogen target. Thanks.
Good morning, everyone. Thank you, Lynette. Very happy to be back here. Still remember all the meetings we had at the beginning of this Barnegat Bay initiative. So cannot believe, right? It has been like more than 10 years. But I'm very excited to share all the progress on the Plan 7, which is adopt more rigorous water quality standard. I'm going to cover the monitoring, modeling, and also the total nitrogen target development. This way. Okay. All right. Lynette already talked about the purpose for Plan 7 a little bit already. So where this Plan 7, we want to have a better understanding of the water quality within the bay, the extent and then the location of the impairment. And also we want to build a good model which can predict the situation within the bay, direct us to for the TMDL development. And based on the response to the pollutant load and also the water quality target we pick, we will be able to identify loading reduction from various sources and guide the restoration effort to achieve the improvement of the water quality within the bay. So start with the monitoring. People always ask, why you need more data? Yes, we do have data. We have all the data, we have the historical data. But when we took a closer look of those data, we noticed that they were not collected from the same time frame, and they do not have a good spatial coverage. And then when you check the parameters or the analytical method, they were not consistent. Okay. And then from the modeling developer perspective, we do need a comprehensive data, which, ideally collect from the same time window and from the location which are spatially representative. And also, we need not just the water quality data, we also need the flow data. So that's why we designed this target monitoring, we want to have a unique data set which will serve us not just to have a good water quality assessment, but also to support the model development. The target monitoring, it was from June 2011 to June 2013. And then we did both flow monitoring and also water quality monitoring. The flow monitoring was conducted together with USGS. It's along the tributary, also within the bay. Along the tributary, we rely on the gauging stations and also manually sample flow. Within the bay, we rely on the gauging station and also the tide gauge. For the water quality sampling, we actually get more partner involved. So we did a discrete sample. We also deploy buoys to get the continuous monitoring data. We also have a special event we call the intensive sampling event. I will talk more about that in the following slides. So this map shows the station where we collect the flow data. So we have a total 17 gauging stations, 7 of them along the tributary, 3 of them is at the Bay Inlet, the Little Egg Harbor Inlet, Barnegat Bay Inlet, and the Point Pleasant Canal. We have 3 gauging station in the bay, which along the bridge, the Mantlocking Bridge, the Route 37 Bridge, and Route 72 Bridge. For the tributary station where we do not have a gauging station, we collect the flow manually when we went out to take the water quality sample. This map is show the water quality monitoring station. We have a total 12 tributary stations. So as you notice, we use BT. So B is the Barnegat Bay, T is the tributary. So we number them from 1 to 12. That's from north of the watershed to the south of the watershed. So BT1 is the Matitican, and then the BT12 is the Westcon Creek. We took the grab sample. For most of the station, we took the grab sample, but we do have one fixing station, which is one fixed continuous station, which is at BT03. That's the Toms River at Toms River. We have 15 stations within the bay, so that's a good spatial coverage. For most of them, we went there on the boat, take the grab sample, but we do have 4 buoys we were able to deploy to get the continuous reading for certain parameters. That's temperature, DO, and specific conductivity, and the chlorophyll A. For the discrete sample, we did collect the field parameter, same as the buoy is the temperature, DO, pH, specific conductivity, and we were able to calculate the turbidity. But we also send the sample to the lab to analyze a suite of parameters. For those suite of parameters, we pick based on our research for other estuary program when they develop their eutrophication model. You know, he does mention the eutrophication, so that's the eutrophication model we evaluate, and that's the suite of parameters we decide to analyze. So that's total nitrogen, that's nitrogen species, phosphorus, silica, TSS, chlorophyll A, BOD, and then organic carbon. For most of the sampling we took, we call the discrete sample. So it's the frequency varies a little bit. During the growing season, that was a weekly sample, and during non-growing season, that was bi-weekly or monthly sample. It's basically we went out to collect 1 sample per day at that station. We also have that intensive. Why we call intensive? Because that is the event we went out to collect 6 samples in the same day. And then it ran 4 days per event. So we had 3 intensive events 2 in 2012, and then one in 2013. So this is the scope of the intensive monitoring. So we did that in 27 sampling locations within the bay and along the tributary. We had 6 boats involved, and there were 13 sampling team. And then it's 75 people per day get involved. And we collect more than 4,000 samples through the intensive. The reason we want to do the intensive, we want to check, is there any daily variability of the water quality? This is this figure shows the sample collection and the transport logistic. So you can see on the boat, that's the monitoring on the bay. And then by the bridge, that's the tributary monitoring. So we have different partners help us. And then after sample being collected, they will transport to the FRAC, our least point lab, to processing, because some sample we need to do the dissolve phase. So we have to get the filtration done there. So after the sample were filtered or preserved, they were sent to different lab for different parameters to be analyzed. We have a total 5 labs involved. So I have all of them listed here. So most of the analysis was done at the least point, but we have the Ocean County Utility Authority to analyze the BOD. We have EPA Region 2 Edison Lab to analyze the silica. And then Maryland University Lab, they analyze the organic carbon from the saline water. And the Department of Health lab, they also help us to analyze some samples. In addition to the lab, we also have other great partners, 11 of them. They help us to collect the sample, we're processing the data. So that's all the logo of all the partners. So, we are very, very grateful to all the great contribution the partners put into this monitoring effort. We know without them, we would not be able to collect that many data in such time window. So, thank you. I just want to give you some quick review about the data we collect during that period of time. So in the following 3 slides, just the total nitrogen concentration. The first one is the average concentration of total nitrogen along the tributary stations. So it's, as you can see, BTO1, that's the Matiticon, and then go all the way down to the southern part of the watershed. Clearly, the total nitrogen concentration in the northern part of the watershed are much higher than the concentration in the southern part of the watershed. But interestingly, you notice the BT11 has a higher concentration compared to other tributary in the south. BT11, that's the Mill Creek. The concentration of the total nitrogen in the northern part of the station is around like 0.8 or 0.8 to 1 milligram per liter. Remember, we collect the flow. Why we need the flow? Because when we have the flow, when we have the concentration together, we can calculate the mass of the nitrogen enter into the bay. So this is the total nitrogen loading from each tributary station coming into the bay. So this, even though, the BTO1 had the highest concentration, but since BTO3, which is the Toms River, they have the highest flow. So therefore, the highest load of total nitrogen come from Toms River. We also look at the in-bay total nitrogen concentration. So as you can see, the highest concentration, that's the right dot on the map, that is BBO4A. So that's by the Toms River estuary. So in general, the total nitrogen concentration in the bay is higher in the northern part of the bay than in southern part of bay. But we do have some relative hot spot in the southern part of the bay. As you can see, the green dot on the map, that's BB11 or BB10. Okay, so that was the target monitoring. That's for those two years. We did not stop monitoring after that. We actually have been conduct long-term Barnegat monitoring since 2013. We developed a QUAP every 5 years. We made some adjustment on the sampling location or sampling frequency, but we already finished 2 of them. So that's 2013 to 2018. That's the first 5-year long-term monitoring. And then 18 to 23, that's the second year. Right now, we're just the beginning of the third year, 5-year monitoring. Bob Schuster will talk more about that in his presentation. Okay, so we have all the data, and then the data is for the good use. Per the Federal Clean Water Act requirement, each state needs to submit an integrated report every 2 years. That integrated report is to assess the quality of water across the state for the designated use, which including the aquatic life, recreation, water supply, fish assumption, and then shellfish harvest for consumption. So using the data we have, we need to compare the data to the applicable water quality criteria. If the reading is beyond the limit set by the criteria, that means a violation happened. Given the frequency of the violation, if the frequency of violation exceeds the threshold, we will consider that water body is impaired for that parameter. We use the data we collect from the Barnegat Bay, and then we compare the applicable criteria. So this is what we have from the 2022 integrated report, the assessment result for Barnegat Bay, both watershed and the bay itself. The first one on the left, that's the dissolved oxygen. So you can see that we have a bunch of dissolved oxygen impairment, but only one of them is in the in-bay assessment unit. That is the Matiticon estuary. So this is, it's on the top part. So maybe you cannot see clearly since that's next to a tributary assessment unit. But for the turbidity that's on the right side of the map, we have 3 assessment units within the bay are listed as turbidity impaired. For those impaired water body, we put them on a special list we call 303D list. So the Clean Water Act requires for any water body on the 303D list, a TMDL needs to be developed to ensure that the water quality standard can be attained. So what is a TMDL? So TMDL is the total maximum daily load. It's both a quantitative assessment of pollution sources and pollutant reduction needed to restore and protect water, and a planning process. So planning process for attaining water quality target. You consider various source for the loading. This, it gave you idea about TMDL development process. So the first one is say when the water is impaired, and then the second one, we need to assess the pollutant source. The third one is we need to construct a model, or we need to find a technical approach to figure out what's happening, right? And then the next one is we need to determine the appropriate source reduction. And then we need to do the implementation in order to achieve what we want. So that's about half of my presentation. I don't know if you have any question I can answer before I move on. Yeah. That's a very good question. Yes, this TMDL is target on to achieve the water quality target within the bay. So we are going to require the reduction of the loading coming from the tributary. So when we achieve those reductions, it would definitely help to improve the water quality along the tributary. And then we do have some study going on within the watershed, and that will help us to check the improvement on those areas. Yeah.
Good morning. We have two questions online in the chat. So we have one from Christian Mansilla that says, "Good morning. Did you collect vertical profiles of water quality, like temperature, DO, and chlorophyll?"
So for the dissolved oxygen, you mean the threshold? That's the value we use? Is that the question?
It's more general than just DO. I think it's just saying for all of the parameters. For any parameter, did we take vertical profiles?
So you mean collect the sample? We do have, for some stations, we collect the both surface and the bottom.
Okay.
Yep.
Yes. Okay. I think that answers the question. And then from Paul Shore, what is the flushing rate?
I'm not sure I will be able to answer that question later. I think the flushing rate means the residence time within the bay.
Yes.
I will be able to answer that in the following, in the second half of my presentation.
Okay. Yes. All right. And then one last one from Robert Nicholson. Do loadings include nitrogen from the ocean coming in through the inlets?
Yes. Yes, that's a very good question. I will also talk about that in my modeling session.
Great. Thank you.
Yep. Thank you. I'm going to move on. Okay. Remember, in the TMDL development process, and then the third one is we need to come up with some technical approach, maybe a model to understand what's going on, right? So what is a model? A mathematical model is an idealized formulation that represents the response of physical system to the external stimuli. We normally, we have water quality model, which is to simulate the pollutant, the fate and the transport of pollutant within the water body. We also have a hydrodynamic model, which is to simulate the movement of the water. Model always sounds like, like a scary term, but actually we do have model in our daily life, right? Today is a cold day. I don't know how many of you actually check the temperature. So the weather forecast, that is the model. And then, sometimes we are all care about the air quality. So the air quality modeling is also a model in our daily life. And the model could be simple, could be complex. I don't know if you use any spreadsheet, the spreadsheet calculation can be called as a model, even though it's simple. But most of the time when we talk about model, it's a complex model. For Barnegat Bay, it's such a complicated system, right? So we want to have a good understanding on what's going on spatially and temporally within the system. And we want to know how the bay will respond to various loading. And we would love to answer some what-if scenario and then be able to predict the future situation. So that's why for Barnegat Bay, we need a complex dynamic model. This schematic shows the Barnegat Bay work and its relation to modeling and management. So in the middle of this, that's on the left, the hydrodynamic model, and then on the right, that's a water quality model. And on the top that, for the hydrodynamic model, you see we have the flow monitoring, we have the sea floor mapping, so that's the bathymetry survey we did. And also we did sediment study. We got some information from the sediment study, which was put into the hydrodynamic model. For the water quality modeling, all the water quality data we collected was entered into the water quality model. And also we obtained some information from the research project that was part of the input as well. We have the air deposition that is all provide useful information to the water quality. So with the model 2 setup, that will allow us to do the management decision. Lanai talked about some of this already, but I just want to repeat here. In addition to the model development, we did do other studies to support the model. So the bathymetry survey, and then we also established an air monitoring station within the watershed, so that will enhance our estimation of the air deposition loading within for this specifically for this model. We had the bathymetry nutrient flux and the sediment oxygen demand study. We also correct the suspended sediment concentration and flux. That was able to improve our boundary input and that was helpful for the model calibration. We also did the shallow water sediment resuspension lead attenuation study. That's the parameters we were able to plug in to set up the water quality model. And all the 5 projects, they were conducted by USGS. Okay, so that is the 3 parts of the Barnegat Bay modeling. Let's start from the bottom part. The bottom part is the hydrodynamic model. And then using the linkage file, the output from the hydrodynamic model was able to be sent to the water quality model. So the hydrodynamic model simulates the water level, velocity, and then the circulation pattern, and also the temperature and the salinity. All those information were processed by the linkage file and then passed that to the water quality model. We use WASP as the water quality model here. And then the water quality model simulates the spatial and the temporal variation of the water quality, the nutrient species, and also dissolved oxygen. We have the phytoplankton dynamic considered in the water quality. We also have the sediment diagenesis. This is the hydrodynamic model. Hydrodynamic model was developed by USGS Woods Hole office. There are total 7 vertical layers. And for each layer, we have 160 times 800. So that's total. That's about 128,000 grade for each layer. And then we're using different source of data to set up the model, including the tidal forcing, and then the reading from the gauging stations, and also meteorological forces, and then the offshore forcing. So that's all the information we use to set up the hydrodynamic model. The hydrodynamic model simulates the temperature and the salinity. So this is on the left, that's the temperature. As you can see, it's about 4 degrees C higher than ocean in the shallow bay water. And this is before the shutdown of the power plant. That's the temperature simulate. That's before that power plant closure. On the right is the salinity distribution within the bay. So you can see that the lower salinity is in the northern Barnegat Bay area. That's to answer that question. This is the simulation to figure out what the residence time. What does that mean, the residence time? That means if a particle enter into the water body, how long it will take there to get out. So in average, it will be 13 days. But of course, it will vary by location. As you can see, the blue is the shorter residence time, and then the right will be a longer residence time. So we do have the largest residence time happen in the northern part of the bay near Toms River, Kettle Creek. In the southern part of the bay, that is the Little Harbor Marsh Islands. So that's from this map, you see their residence time around like 30 days. The hydrodynamic model also simulates the water level. So when we have the simulation out, how did we know the model is doing a good job or not? That's we call calibration. So we compare the simulate result to the observed. So as you can see here from this plot, we have the data that's blue, and then the right, that's the simulate by the model. When we notice the observed data match the simulate well, that's the time we can see the model is well calibrated. Next, this is the water quality model. Water quality model was built using WASP model. It was developed by USGS West Trenton office. This one, we only have 3 vertical layers. And then for each layer, we have 609 grades. So it's much coarser compared to the hydrodynamic model. And we have a bunch of simulate parameters, including nitrogen species, phosphorus species, phytoplankton, silica, and BOD, and also chlorophyll. To set up the model, we have to know what's the loading from various source. So that's the question. The major loading source from the monitoring subbasin, so where we use the collect data to collect the loading, to calculate the loading. And then we have the loading coming from the unmonitored subbasin. So that could be direct runoff or direct groundwater discharge or marsh estuary interaction. We also quantify the loading from atmosphere deposition. We also have the loading from the sediment, that is the benthic sediment flux. Of course, we have the loading from the ocean input from all 3 inlets. So we quantify all of them. This pie chart, to give you idea, was the distribution of the overall loading from various sources. 38% of the total nitrogen coming from the stream and the river, so this is the largest one. But the loading from the ocean inlet, that's also a big part, that is 29%. So that's the second largest one. For the water quality model, we did the same thing. We simulate the result compared to the observed. This is the total nitrogen concentration simulated for various stations, both surface and the bottom. So the predict one is the blue, and then the dot is the actual data we collected. So you can see that for some station, it match very well, but for some station, there's some difference between the observed and then the simulated result. Another example is the water quality calibration is the chlorophyll A. Again, the simulate is the blue, and then the black dot is the observed. So that is calibration. But when can we say the model calibration is good enough? We have a model evaluation group formed in 2019. Their responsibility is to provide an independent, objective review to determine the adequacy of the calibration, the strength and the weakness of the calibrated model, and then to see if the model can be used for the TMDL development or for the site-specific criteria development or for any other management decision-making. So we have 4 members. They are all experts in the hydrodynamic or water quality modeling for the estuary program. It took about 1 year for them to finish their review, and then each of them gave us their detailed comments. To summarize their comments, we received some good news or bad news. So the bad news is the model does not do a good job to catch the daily variability of the dissolved oxygen within the water body. And then the model cannot be used to address the turbidity. So remember those 2 assessment results, the DO and the turbidity. We are hoping to use the model to develop the TMDL for those. We cannot because the model does not do a good job for those 2 parameters. But they also gave a good news. They saying the model provide a reasonable representation of spatial and temporal distribution of salinity, nutrient, that's both total nitrogen and total phosphorus, and chlorophyll A. So when we see that comment, we are very happy. Why? Because even though we do not, right now, we don't have an existing total nitrogen criteria, but remember the research project. We have, under the Plan 9, Lanai just covered, we had 10 research projects. 3 of them, we call the biocriteria project. So that's, highlight that's number 1, number 2, and the number 6 on this table. So that's bathymetry, benthic macroinvertebrate community evaluation, and then the diatom study, and then the phytoplankton. Those 3 biological indicator study, when we work on them, we were hoping to identify the level and the course of ecological impairment, and then to figure out if there are any correlation between the biological impairment with the water quality. So the water quality was focused on the nutrient, phosphorus or nitrogen. We did not get any promising result from the phytoplankton or diatom study, but we got very exciting result from the benthic macroinvertebrate study, which was done by Gary Tagon from Rutgers. So that project was done from 2012 to 2015, 4 years. And for each year, we collect the data from 100 locations within the bay. We collect the surface sediment sample, and then they analyze the species of the benthic macroinvertebrate. They group those species into 5 ecological group. So, and then one of the group we call the sensitive species group. For those species, that means they only survive with the normal water condition. So if there is a stress in the water condition, those species will not be happy. They will not be able to survive. We match the water quality data with the benthic macroinvertebrate station. So we group them. And so for the same station, we are able to do a stepwise linear regression on the water quality and then the abundance of the most sensitive species. That analysis gave us this correlation. This is a linear correlation. The x-axis is the average total nitrogen concentration in the water column. And then the y-axis is the proportion of the sensitive species. So after 4 years data, they developed this correlation and also they validate that correlation. As you can see, in order to have a good portion of sensitive species, we need to control the total nitrogen to be a certain level. Based on, we also look at other estuary program, and then we pick 450 microgram per liter, which is also 0.45 milligram per liter as the total nitrogen target, specifically for Barnegat Bay. If we can achieve that concentration, we hope that the sensitive species of benthic macroinvertebrate will be about 25%. So how does the concentration we observe from the bay compare to this 450 microgram per liter? This is the summary of the concentration we observed since 2014 to last year, 2022. BBO4A, that's by the Toms River estuary. As you can see, for that location, almost every single year, we have a concentration higher than that threshold. So on the map, that right line indicates that 450 microgram per liter. When we move to the central part of the bay, BBO7A, the concentration much lower. We only have like a couple years with a spotty reading exceed that threshold. In the southern part of bay, BB09 or BB11, they gave us pretty much a similar information. So the concentration in general lower, but we do have some year with the concentration higher than that threshold. So that's the actual data tell us. Remember, the model also simulate what's going on within the bay, right? So this is the simulate concentration total nitrogen. As from the color, if you see any orange, the orange is 450 to 499 microgram per liter. And then you notice that northern part of bay, they have a total nitrogen concentration higher than 450. While in the southern part of bay, they're not in orange color, but they're in the right color. So that means they're in the edge to exceed that threshold. So if we want to achieve this specific target, 450 microgram per liter as the total nitrogen, we need to reduce the total nitrogen loading coming into the bay. How can we achieve that? We are going to reduce the loading from the source we can reduce. So we decide to require the reduction from both northern part of watershed and southern part of watershed. But we're not going to ask the same reduction from everywhere. We run different scenarios. So this table summarizes the result of the various simulation. The last one as a highlight there, that's 80% reduction from northern part of a watershed plus 20% reduction from southern part of a watershed. We will be able to achieve that 450 microgram per liter at every single assessment unit within the bay. So that's a total 9 assessment unit. So as the number indicate there, we will be able to achieve the concentration of total nitrogen less than 450 when we have that 80 and 20% reduction. So this will be the basis for us to develop the TMDL. That will be the guidance for us to work on, to implement, and then achieve the water quality target. This is the set specific target we developed for the Barnegat Bay. That's all I'm going to talk. Is there any additional question?
Here, I have a mic real quick. I'm coming to you.
Thank you. Am I being heard?
Yeah.
I think the answer to my question was probably in your presentation, but I just didn't get it. You showed a pie chart, and it showed the percentages from various sectors of contributing nitrogen into Barnegat Bay. And it said that 29% is imported from the inlets. Is that 29% figure achieved by actual measurement? In other words, do we get it empirically, or is it built on a model?
When we set up the model for the calibration, it was estimated using the actual data. So we did collect the sample from Barnegat Inlet, collect the sample from Little Egg Harbor Inlet. So those concentration was used to estimate the loading from the ocean.
And I think the answer to my question is there wasn't this kind of follow-up, but was there, and if there wasn't, why not, a follow-up by doing isotopic studies to find out where the nitrogen being imported by the inlets actually came from? Because it could be atmospheric deposition, or it could be from the sewage treatment plants coming back into the inlet, or it could be other sources. And I think that isotopic studies are how you get to the bottom of that. I know that the U.S. Geological Survey uses that method sometimes. Was that further study done or not? Because if it's from sewage treatment plants, then that could start us down the road of really getting some nitrogen out of Barnegat Bay.
Yeah, I think that's a good suggestion. I don't think we have those study done yet.
Yeah, I just want to build on Willie's question. Was that surprising that 29% was coming from the inlets?
That's what the data tell us.
That's what, yeah, I know, but was anybody expecting that much of a loading from the inlets? Just curious. And the other question I have is, could you just explain the benthic nitrogen flux, the 14%, how that could explain what that loading is from? I'm assuming it's from sediment, but.
Yes, that's from sediment. Yes, just like in this slide with regarding the loading source, that's the 5 major ones. So this one is that's this one, the benthic sediment flux.
I guess I'd add a little wrinkle on that. You'd not only have to detect that stable isotope ratio, you'd have to pin it down to actual dischargers, which I think would present a more challenging question because of the stratification off the shore, and some are a lot. New York bight waters might upwell into the area, but the Ocean County dischargers are a pittance compared to the discharge by New Jersey and other states into the New York Bight. Oh, no, I'm not opposed to that. In fact, I think you and I have had this conversation a couple of times before. Um, I, it's just, it becomes an interstate issue there. And it's just in terms of locally addressing that just becomes sort of a bigger picture question for the state and others. So I think it should be answered. It's just, it might be more of a challenge than any of us know.
Any other in-person questions?
Thank you. I'm just curious, like the higher nitrogen loading in the northern bay compared to the southern bay, is it more related to like higher residence time on the northern compared to southern, or is it more related to like the possible difference in terms of the input depending on the different region, like coming from the terrestrial, from the runoff or other things?
I think it's both. It's the loading from the tributary. And also we noticed that the Point Pleasant Canal coming in, that's also provide a higher concentration than the Barnegat Inlet and the Little Egg Harbor Inlet.
Good, thank you.
Is the report of the MEG publicly available?
You mean the benthic invertebrate
Well,
report?
MEG, remind me what MEG stands for.
Oh, sorry. No, we don't have that public available yet.
And will it become available publicly?
With the TMDL, yeah.
So it will be posted? And will all of the studies and all the documents, everything that they used to come up with their comments also be publicly available and be posted?
Oh,
Well, I've been told that we have to talk into microphones because people who are listening remotely need to hear us.
When the department proposes the actual TMDL, all the supporting materials will be made publicly available, or access to them will be made publicly available.
Everything that the MEG took into account as it wrote its report?
Yes.
Thank
Yes.
you.
Okay, so we have a few questions online on the chat. I'll start with Christian Mancilla's question, which is submerged aquatic vegetation the end target of controlling turbidity?
I don't think it's only a turbidity issue.
Okay, so we have another question from George Murniak. What is sediment diagenesis in model?
Oh, that is that's the module of the model to simulate the benthic sediment flux.
Okay, thank you. And then Murray Rosenberg asked, were modeling scenarios for potential future impacts of climate change incorporated into the dynamic modeling?
I don't think so, but we could add that consideration. That will impact the temperature.
Christian Mansella asked, is the 0.45 milligrams per liter total nitrogen criteria not to exceed, or is there an exceedance frequency in the criteria?
Okay, yeah. I want to clarify this 450 microgram per liter is seasonal average. So that is from July, I think it's on one of the slide. I include there, it's the concentration from July 1st to September 30. So that is the average period. So simply speaking, that is just the summer average. So if the concentration over that period of time exceed 450, that will be considered as a violation.
Thank you. Robert Nicholson asks, do loads from the Manasquan Inlet implicate a need to manage loads from the Manasquan watershed?
It's also a very good question. Yes. When we set up the future scenario for the reduction scenario, we assume the concentration from Point Pleasant Canal will be improved in the same situation as Barnegat Inlet and the Little Egg Harbor Inlet. Even though the observed concentration based on the actual data, the concentration at Point Pleasant Canal are definitely higher than Barnegat Inlet and Little Egg Harbor Inlet.
Thank you. And then another two from Christian. The first is, how did you account for the difference in hydrological years, meaning low flows, high flows, etc.?
So flow, the model, the hydrodynamic model simulation period, that's the March through October of 2012. So when we look at the data, that year, it's kind of like a representative.
Thank you. And then, was there a significant reduction in sediment nutrient fluxes under the reduced load scenarios?
It's not a significant, but we were able to adjust the number based on some empirical model or empirical relationship.
Then from Charles Caruso, the 60-20 reduction for Toms River appears to meet the 450 target. Is that reduction being considered for Toms River rather than the overall bay target?
We don't have that kind of separation just for like a local assessment unit. So this 80-20 split, that's what we normally do, just, separate different regions.
Thank you. And the last question is from Paul Shore. How do historic loads from septics and SCPs discharged into back bays from 1970s get recognized in model, and how long will they take to be reduced?
That's depending on, the impact of those to the data we collect. If the impact of those still there, that should reflect in the concentration in the sample we collect that was considered when we set up the model.
Okay. And then, I'm sorry, one more from Paul Shore. What nitrogen targets for Delaware Bay or Chesapeake Bay? What are nitrogen targets for Delaware Bay or Chesapeake Bay?
I don't think there is a number for Delaware Bay. I don't think there is one yet.
Okay.
But Chesapeake Bay, it varies by region, so.
Okay, thank you. That was the last question from the chat.
Okay. Any other question? Okay, I think we are supposed to have a break.
Well, thank you, Helen. That was an amazing presentation. Even though I've seen it before, I think you did yourself explaining a lot of technical information in a very concise and straightforward manner. And I know we had a lot of good questions on the science. And so this is the first of 3 sessions that we were anticipating having. The second session would be devoted to just the science, to hear more about the USGS models from the modelers themselves that developed them for us. In addition to that, the background studies that went into the information that Helen had in that schematic that showed the 2 different models and the different components that went into that. So our second session would be all about that, delving much greater in details into that. We had a question about the model evaluation group and their review and what data is available publicly from their input into their critique of the model and how it predicts for the TMDL and for the total nitrogen target that we have proposed here to you today. So that would be the second session. So those of you that are interested really to, rolling up your sleeves and digging into the science, we'll have a 2 or so hour session on that. Has not been scheduled yet. It will be sometime in the new year, but that's just a preview of where we're going with this. And then our third session would be all about implementation. And I know that we are already receiving questions. Why is it 80% and not 60% for my municipality when we could achieve that to meet the target number? Well, we'll delve into that a lot more in an implementation session, and we'll talk about what that entails and what the municipalities would do. But for the next session, we have built on now that we're talking about the Barnegat Bay TMDL, we wanted to also lay out various ongoing initiatives that are already having happened in the Bay. Lynette talked about the 10-point plan, and she pointed out several times where there was Section 319 non-point source funding that led to particular projects. And so our third session would be a lot more about implementation. So today we have a few speakers that are talking about current ongoing projects in Barnegat Bay. And those projects will be part of a TMDL implementation plan that is already working towards achieving that 20% and 80% reduction. So I wanted to pick up where Helen had started to talk about what is the TMDL and an overview of the program, and then really focus on the TMDL implementation plan. So real quickly, I'll reiterate what is the TMDL process, components of a TMDL report, and more about the TMDL implementation. We said this before, TMDLs are required under Section 303D of the Clean Water Act to be developed for water bodies that cannot meet surface water quality standards after the implementation of technology-based effluent limitations. That's a mouthful. We've talked about we're establishing site-specific criteria in the watershed, and in order to attain that target number, we'll have an 80% reduction required and a 20% reduction requirement. And TMDLs are required under our New Jersey Water Quality Management Planning rules for water quality limited waters. That is the 303D list that Helen was talking about. And then our rules also talk about a requirement to have a TMDL implementation plan, which includes the strategies designed to achieve attainment of the surface water quality standards. So the federal rules do not have this requirement. EPA in their guidance asks that states include an implementation plan, but our regulations actually require it. A TMDL, again, represents the assimilative or the loading capacity of the receiving water. It takes into consideration point sources, non-point sources, background conditions, and surface water withdrawals. Helen talked about what that entails, and that I would reiterate that the load allocation is the non-point sources. So as we do not have major point source dischargers in Barnegat Bay, this TMDL is all about the loading reductions from non-point sources. And Helen talked about simple versus complex models, and simple mass balance models are those spreadsheet calculations. But as you could tell from Helen's presentation, this clearly was a dynamic water quality model. So this is what we call a complex model to develop our TMDL. Back in 2002, EPA issued guidance on what states have to submit to EPA as far as components of a TMDL document. It starts with the source assessment, characterizing and quantifying as necessary the loading and the parameters in the watershed. You have to talk about your point sources and non-point sources and any background. You do your water quality analysis. That was the portion that Helen presented here today. That will be written up and put into our TMDL report. It will show the basic calculations that were done to achieve our target number. Then additionally, there's a reasonable assurance component, which I'll talk more about in a moment. Follow-up monitoring, which you'll hear about from Bob Schuster, our ongoing initiative, implementation, and continued public participation. So those are all the components of a TMDL report. And as asked previously, all the source documentation that goes into developing the TMDL will be identified in our reference section. There'll be appendices to our TMDL report, and all the information is made publicly available. It exists in many places, in various places at the time, but we pull it all together into one location for the TMDL report, and it would live on our department's website as well. So just to be clear, through the TMDL, we're proposing this nitrogen water quality standard. So after the TMDL model is set up, the target standard is used for the scenario development. Reductions are determined at critical locations in the watershed that are needed to achieve the water quality target. The New Jersey surface water quality standards allow, through the TMDL process, to determine a site-specific criteria to be applicable to a particular watershed. And as Helen said, we did not have a standard for these water bodies for nitrogen. And so the TMDL is establishing a site-specific standard for the Barnegat Bay Huck 14s. And through the TMDL process, we are creating a surface water quality standard unique to Barnegat Bay. The TMDL with the water quality standard are subject to formal public comment when we propose it in the New Jersey Register. As part of that process, we propose the TMDL as an amendment to a water quality management plan. In this case, it would be the Ocean County Water Quality Management Plan. Again, it goes in the New Jersey Register. It's subject to public comment. We do a response to comment document. We then submit it to EPA for formal approval. EPA reviews and has been reviewing our work along the way. And then it is adopted after EPA approves it as an amendment to the specific water quality management plan. And as I had said, we have an implementation plan component within that TMDL document. So the department, once the TMDL adopted, when it issues permits, they need to be consistent with the language in the TMDL. This it usually transpires when you're talking about an Egyptes permit and point sources, and you have a target reduction required. But in this case, since we're talking about non-point sources, we also will talk about our stormwater permits through the municipal stormwater program. So that will be included in the TMDL implementation plan. And again, our third session where we talk only about implementation, we'll go into much greater detail of what that would look like. So any questions that you have in advance of that, we would want to know so that we're prepared to answer and have presentations to that. Again, that will take place in the new year. Our TMDLs in the implementation also talk about other measures that could be appropriate. So is there additional ordinances, or is there additional things that should happen in the unique to Barnegat Bay watershed to attain the reductions required to meet the total nitrogen number? And then we also talk about ongoing projects, which you'll hear some of after my presentation, and other initiatives and projects and best management practices that will also get us towards the 20% and the 80% reductions. And then we would talk about Section 319H funding and other funding to implement TMDLs. A unique thing to our water quality management planning rules is that it has this requirement that all projects and activities affecting water quality in any planning area shall be developed and conducted in a manner consistent with that area-wide plan, and that the commissioner shall not grant any permits which conflict with an adopted area-wide water quality management plan. So again, the TMDL is proposed and then adopted to the Ocean County Water Quality Management Plan. This is the pie chart that you saw that USGS prepared, and Helen had that in her presentation. So the key takeaway for me from this slide as well is that regulated stormwater and non-point sources are important to reduce. You saw that the surface waters are contributing 38% reduction, and then the inlets an additional 29%. These are our targets of where best management practices, education outreach initiatives can happen to get us towards those reductions. And as I said previously, we would do that through the MS4 permit. We pointed out that we already have a statewide fertilizer law that is also getting us towards reductions. We have existing stewardship projects. And then we heard about the water bank, the loans, the monies the millions of dollars that have been made available in the past 10 plus years in Barnegat Bay. So the TMDL has this requirement for reasonable assurance. So the TMDL should provide reasonable assurance that the regulatory and voluntary mechanisms will be applied so that the pollution reduction levels specified in the TMDL are achieved and the standard is attained. So that's a section in our document where we talk about all these ongoing initiatives and future initiatives that will get us towards meeting these requirements. And again, this is a reiteration of existing things. And the takeaway for you is while that 80% may sound like an enormous reduction, there's many things ongoing in the watershed that are already getting us towards that 80%. It's not a one-for-one. We're not saying this BMP in this township has to be 80% getting us towards the total nitrogen target. It's the accumulation of all the things in place, the regulations, the stormwater permits, the voluntary measures, the education outreach activities, and then you'll hear from other speakers on watershed protection plans, watershed restoration plans, and how those projects in very specific watersheds are drilling down to where the sources of the nutrients are coming from and are doing site-specific source control measures and projects. That's what will get us towards the reductions that are required. Are there any questions? Okay. Our next few speakers, you will hear about some of these stormwater and outreach initiatives. Again, as I said, these will be incorporated into our TMDL implementation plan. And then next up, we have Bob Schuster, and Bob will be talking about the ongoing monitoring in Barnegat Bay. So again, this is part of our reasonable assurance. Crystal, we have a question?
Yes, we had a couple questions come in. So there's one from George Murniak who says, has anyone calculated an estimate of total cost to date, NJDEP and EPA, on Barnegat Bay environmental improvement programs?
We have not done that analysis, but we certainly have the information to put some of that together.
Okay. And then one more question from Kim Kramer. Are the regulated permitted MS4s permitted under the CWA or New Jersey?
It's a federal requirement, but under New Jersey's laws, So they're permitted from New Jersey DEP.
Okay, thank you.
Yeah. And again, that will be in much greater detail in follow-up sessions. Okay, I'm going to turn it over to Bob, and we'll hear more about the monitoring. And then we'll be followed by Rob Carl from BRIC MUA, who'll talk about the Metedeconk Watershed Restoration and Protection Plan and various implementation projects. And Dr. Stan Hales will then talk about the Toms River Watershed Plan goals and objectives.
Hi, I'm Bob Schuster. I'm with DEP. I had a long career at marine water monitoring, have now moved into watershed and land management as watershed coordinator. I'm grateful to be here speaking about this today, as we've been involved with Barnegat Bay for a very long time, both the shellfish program side of my career and moving forward into, the nutrient side. Right now, what we have is monitoring of the tributaries and estuary. It continues. It was mentioned we're now in the third crop of a 5-year crop. This is the study of all the nutrients and water quality parameters that we started at the beginning. So one of the key points of why we're doing this and why we continue this monitoring, as all of those plans that you hear about are being implemented through 319 grants, how would we know if there's anything changing if we don't have all of that data and continue to collect that data? So the long-term monitoring as we issue out these grants is a very key component, because we want to know what changed, how much changed, and if we're seeing that benefit and what works and what doesn't work. All of the samples and collection of the marine samples are done in marine water. We have freshwater and biological monitoring DEP doing the tributaries, as well as a few partners that are still engaged. But having them all analyzed at the Leeds Point lab is keeping consistent with all the previous data that was done throughout that intensive part that developed the TMDL. We had 4 buoys originally. We added a 5th. We now have it in the Metedeconk. I will show a map shortly. But we also support 3 working with Barnegat Bay Partnership to host them on the same webpage. So there are 8 continuous water quality monitors throughout the bay that will get us 15-minute data for pH, salinity, dissolved oxygen, temperature. So this is an ongoing effort. We're going to continue this effort because, again, we need to keep the information flow coming in to know if things are improving and how things are changing over time. The advantage of continuous is it gives us that diurnal change that you might not get in a crab sample. It gives us that seasonal, how it changes throughout a day, through season. So it's very important to have that to know what's going on. So all of this is, to monitor and see what's changing if things were implemented and what happens, and to identify hotspots. One of the things that we want to do is we want to look at those changes. We want to know throughout the estuary, are things getting worse, better? Are we seeing hotspots pop up that maybe we didn't see before? This is an important component that will be discussed probably a lot more in the 3rd session with implementation, because we want to make sure that wherever we're implementing things is in the areas that are the highest priority of where we're going to see the most benefit. So it's something that we're certainly looking to do. Throughout the estuary, these are the stations that continue to get sampled. We're sampling them monthly. So it's throughout the tributaries. I would like to mention that in addition to this, there's also a lot of ambient data at other locations that are not part of this monthly, initiative, that may be quarterly or other frequency, that is done by freshwater and biological on tributaries. That is also being done on marine water for shellfish classification. So there's a lot more information that we can also look at to look for problem areas in addition to what we're seeing here. And that's going to be one of the things that we're going to, look at, really doing that thorough deep dive, looking into that information. Continuous water quality monitors. There are a lot of them out there now. You see a lot of the orange dots or green dots are If they're orange, they're not out anymore for the season. Green are still out. You can see the three green for Barnegat Bay Partnership are the land-based ones. The marine water ones are buoys. We tend to pull them so they don't get damaged in the wintertime. There's also freshwater lake ones, which were added for cyanobacteria blooms, which was something added a few years ago. They're all hosted on the same page. We're actually working with the New York Harbor Estuary Program, start adding more of continuous up into the harbor area besides just what we have in Raritan and Sandy Hook Bay. These are publicly available. So there's downloadable data that's archived. It can be pulled out, looked at by date ranges. Most of these in Barnegat Bay have been out since the 4 have been out since the beginning in 2011 of this initiative. One was added back, I believe, in 15 or 16 into the Matita-Conch. We're also going to institute a project that I talked about with some of the USGS staff here that we had conducted back in the late 90s up to about 1999. We did a land use study where we looked at 4 different land use types. And it was done under storm flow, dry weather conditions. Samples were collected throughout the hydrograph. And it helped us look at what the nutrient loads were from these different land uses and what was making it to the bay. This is something we're going to repeat. We have the QUAP is under review. It's being written. It's under review. Once it's finalized, we will start to collect those samples. It's something that is going to tell us whether, this fertilizer law that went into effect, have we seen a change? I mean, this was done pre-fertilizer law. This was done 25 years ago, some of it over 25 years ago. But once that law went into effect, are we seeing that change? Are we seeing nutrient levels change? What has changed? And how is it being impacted by that law? What we also want to do is I also want to reach out when I talk about hotspot identification. Something we're starting to look at, and we're starting to develop more tools for this, is we want to identify all available data, not just what we collect as part of this Barnegat Bay sampling, but there are a lot of partners. Brick Township MUA has routine monitoring. Freshwater has other locations. There's a lot of partners with data that all goes to the National Water Quality Portal. One of the things that we really want to look at is taking all of that data and looking at it over time, or looking at it over 5-year periods or 2-year periods. We can start to identify where some of these hotspots, where the highest levels of nitrogen are, where they are in the watershed. And that will help inform, as mentioned earlier, where you might want to implement some of these plans, where you might want to apply for a grant, where we're going to see that hotspot location, where we'll see the most out of it. That's something we need to do. We're committed to continue to work. We want to work with local county governments. We want to work with the partnership. We want to keep that dialogue open, because when you go in and pull this data, believe me, you pull 30 years of data and you find out in Ocean County, just from nutrients alone, you probably have 200,000 water quality records. There's a lot to go through, and how to evaluate that, look at it for these hot spots. What can we do? How do we work together to identify where the spots are and take action? And we'll have a lot more to discuss in the future sessions on how to do that. But also keeping those partnerships, it's how we got here to develop the TMDL. Without all the partners collecting samples and partner labs at EPA and MATES, Brick Township, and all of the different partners we had engaged, we wouldn't have been able to get to where we are at this point. So I think keeping that dialogue open, keeping that, feel free to reach out. My contact information at the end, any questions at any time, people want to know more detail, I'm more than willing to work with people. We need to, because partnerships, no one group can cover everything. No township will have all the answers. The state won't have all the answers, but we work together, we're going to be a lot better off. So we need to keep that that whole dialogue open. And it also keeps that transparency and sharing of information so we all know what's going on, where it's going on, how it's going on. It's going to allow to make sure that we get to where we need to be. And by keeping everybody informed, keeping everybody engaged, we're going to be more likely to see success when we do implement these plans. I think it is a really important goal. I think Commissioner Vicari said it perfectly. Is in this room, and through, whether you're in the public or whether you're a municipality or county or federal, in the end, everybody wants to see the same thing. We want to see the water quality of Barnegat Bay improve, and the only way to do that is to keep that dialogue open and make sure we're all working together on the same page to get to where we need to be and want to be. And I think that's one of the most key points. This is my contact information. I will certainly share, answer any questions that anybody has.
So we did receive 2 questions. So we received a couple of questions. 2 were for Kim Seno from her presentation, but I'll do the questions for Bob first. So there was one from Maisie. What changes have you seen since implementing the fertilizer laws?
The fertilizer law was implemented, and we're going to conduct that study to see if we see those changes based on that historical data. So I don't think we've done a full evaluation to see of where that is, but by going to those specific land uses, when we redo that study, we're going to get a better handle on how that law has worked.
Okay. Thank you. And then from Paul Shore, if the nature of an estuary is an ecosystem that place for aquatic organisms, how will that productivity be measured?
I have to think about that one a little bit on how that would be measured on, the ecosystem side, because the target right now is to look at a nitrogen threshold, and our goal is to get to that nitrogen threshold. I think there will definitely need to be follow-up, as far as ecosystem-wise on what that impact is in the future if we achieve this goal. If we get these reductions, what would, we would need to duplicate some of those efforts to see how effective it was in improving that biological component.
Okay, thank you. And then for Kim, it says.
Can I add a comment? I would just add, I actually now feel good that I added a slide to my presentation. We do have an agreed upon suite of holistic ecosystem targets for the Bay. And so I can actually share that list with everybody in a few minutes.
Thank you. Okay, and then for Kim, let me just make sure. Okay. Are the MS4s Tier 1 or Tier 2 the NJPDES, Nativity sources? In other words, are the CWA regulated MS4 point sources?
They are treated as a point source. So it's a non-point source loading for the TMDL calculation, but for the MS4 permit, well, the Tier A, everything's a Tier A permit now in New Jersey, it is treated through that as a point source. It's getting permitted through the MS4 program. We'll explain that more in greater detail at a follow-up session.
Thank you. And Charles Caruso asks, can the TMDL encourage the adoption of a stormwater utility as an additional measure to help pay for the improvements needed to meet the nutrient standards?
I'd like to dialogue with folks on that at a future session, and we'll dialogue on that in the department. If that does appear in the TMDL implementation plan, it wouldn't be a requirement. We'd have to be clear that that's a suggestion. We wouldn't go so far as to make that a requirement. But if there's support for it, we would want to acknowledge that in the TMDL document.
Thank you.
And I'd also like to add to what Bob was talking about, the mid-1990s Toms River study. We also did a similar study in the Whippany River watershed up in North Jersey and Morris County area. And so the plan is to repeat these land use studies that were done, since we have this valuable information from the before time period, before there was the stormwater regulations, before we were doing many TMDLs, before we spent millions of dollars in 319 projects, and before we had a statewide fertilizer law. So have the ability to repeat these studies from the same locations and compare the data, and hopefully to be able to see what reductions, where they're happening, and the nature of that, I think is going to be not just interesting, but hopefully profound contribution to our rules and regulations and what it takes to restore our waters. They don't happen tomorrow. It happens over a period of time. And to have the ability to at least look at that and see what the data is telling us, I think is just really, really interesting. And so I can't wait for those two monitoring initiatives to get kicked off. And then we, the department, will be able to share the results with the public. So I'm going to turn it over to Rob Carl. And Rob will talk about the existing Metedeconk watershed restoration and protection plan. And I'd also like to mention that for the Metedeconk, we, the department, took the information that Rob and his team had put together in that plan, and we wrote a separate protection plan, which we submitted to EPA. So a few years back, a lot of the states got together and they basically complained to EPA. And they said, you're making us do all these TMDLs and these restoration activities. What about for waters that are not impaired and we want to keep them that way? That takes money and effort as well. And you, EPA, aren't giving us credit for that. So EPA said, okay, we'll give you credit for that. But you have to formally write it up, submit it to us, and then they review and they accept that. So we did that for the Metedeconk, and New Jersey was, I believe, the first in all the states to produce a report to that effect, submit it to EPA, and to have acknowledgement of that. So we do have that on one of our web pages. It's a little bit buried, but we'll re-acknowledge that when we put forth the Barnegat Bay TMDL. It's Rob.
Good morning, everyone. I appreciate the opportunity to be here. My name is Robert Carl with the Brick Township MUA. My job there is basically to manage the drinking water supply. For those of you who don't know, the Brick MUA provides drinking water to more than 100,000 people in Brick Township and surrounding communities, including Howell Township, Point Pleasant Beach, and Point Pleasant Borough. We have a 16 million gallon per day water treatment plant and a diverse portfolio of water supply sources, which include the Metedeconk River, the Brick Reservoir, and a series of wells. But the Metedeconk River serves as our primary drinking water supply source. It supplies about 70% of our drinking water supply on average, and it's also used to fill the Brick Reservoir. Here's just a map of where the Metedeconk and Brick MUA are in relation to the larger Barnegat Bay watershed. And you'll see in the map on the right, very little of the Metedeconk watershed lies in Brick Township. So we've had to engage the upstream communities quite a bit through the years for the purpose of water supply and watershed protection. Over the course of about 2 decades, we had done a lot of monitoring, done a lot of studies, and all that really culminated in 2013 when we completed the Metedeconk River Watershed Protection and Restoration Plan. The main goals of that plan are to preserve the Metedeconk River as a healthy and sustainable water supply for the region, to restore and protect the Barnegat Bay estuary, and to eliminate water quality impairments, address TMDLs, and attain compliance with the surface water quality standards throughout the watershed. Our Metedeconk River Watershed Plan covers 90 square miles and 7 municipalities in both Monmouth and Ocean counties. The planning process was guided by a diverse and representative stakeholder advisory committee, And the end result of that is that the plan is built on consensus and is broadly supported. Ultimately, this plan is a strategy for the long-term protection and restoration of the Matineconk River, and it includes a prioritized list of actions and projects that can be implemented by anyone. The plan's not Brick MUA's, it's everyone's plan. So the watershed plan is a pretty hefty document, but in a nutshell, what it does is it evaluates watershed conditions. We looked at water quality, we looked at land use, and we looked at water quantity. When I say water quantity, I talk about hydrology and stream flow changes, but also human use. The plan looks at all the existing TMDLs that are already in place in the Matineconk. There are fecal coliform TMDLs for both the river and streams, as well as lakes. There's a phosphorus TMDL already in place in the North Branch. There's a total coliform TMDL for the brackish water portion of the Matineconk that is geared towards shellfish. And then there's also a mercury TMDL, which has to do with fish tissue and it's the result of air deposition. The plan assesses pollutant sources and establishes loading estimates, and we focus primarily on pathogens, i.e. Fecal coliform and E. coli. We focus on nutrients, nitrogen and phosphorus, and total suspended solids. In the plan, we calculate load reductions required to meet the New Jersey surface water quality standards, which are ultimately rooted in the Clean Water Act. The plan identifies management strategies to achieve these load reductions and presents an implementation program. So we completed the plan in 2013. We've been working on implementation for about 10 years now. And some relevant findings from the plan, really just that are relevant to today's discussion, is that the Matineconk continues to be a very healthy and high quality water supply source for Brick MUA. That's good for us. But we found the stormwater really is the biggest contributor to water quality and stream flow problems. And many water quality parameters, including nitrogen, show increases both over time and with distance downstream. And you can see both of these figures come from the watershed plan. You can see as you move on the right-hand side, the chart, as you move downstream, we can see nitrogen increase. And the map on the left shows nitrogen loading areas within the watershed. And if you compare that to land use and land cover, you can see it aligns very well with impervious surfaces. And that is roads, driveways, parking lots, sometimes lawns that are compacted that aren't allowing water to infiltrate. So really, it's those more heavily developed areas that are contributing the nitrogen loading. So in terms of plan implementation, stormwater being the biggest component or factor we need to work on, it kind of falls into two bins. It falls into new development and existing development. So in terms of new development, we're fortunate in New Jersey that New Jersey has very good stormwater management regulations. And basically, new developments are required to meet standards for water quality, water quantity, and groundwater recharge. The biggest priority project that came out of the watershed plan was the development of a low impact development ordinance. And we collaborated, Brick and a consultant collaborated extensively with DEP in developing this model stormwater management ordinance. And what we wanted to do is really have what's called green stormwater infrastructure added as a requirement within these, as a stormwater ordinance for the towns, as a model ordinance. Ultimately, the key concept that green stormwater infrastructure was adopted statewide in the stormwater management regulations that became effective in March 21. So the work we had intended for the Matineconk, that key concept of green infrastructure was applied statewide, which I think is a great success. And for those who don't know, green infrastructure is really small stormwater management measures, or BMPs, that are distributed throughout the site. So rather than have a basin at the end of the pipe, at the end of the site where it treats everything, you have smaller BMPs like rain gardens or tree filter boxes that are distributed throughout the site. And ultimately, it's more effective to treat the water near the source than it is to work, treat at the end of the pipe right before it's discharged off the site. So that was the new development bin. The other bin is existing development, and this one's a little more difficult. There's countless basins and direct stormwater outfalls where the water runs off the road into a storm drain and right to the nearest stream. The map on the right shows all the direct discharge outfalls we identified in the Matineconk, and I can guarantee you that's not all of them. But that's what we had identified when the watershed plan was being put together. So I wanted to walk through briefly some of the implementation projects we've done, both Brick MUA and partners, to deal with antiquated stormwater management. The first project we undertook was in Moses Mills Drive, on Moses Mills Drive in Howell Township. It was a project we did in partnership with Howell. Here we had a huge traditional detention basin. The water comes in one side, races down that low flow channel, and right out the other side. Does nothing for water quality, and really was just designed for flow control. What we did was we eliminated that low flow channel. We broke up the soils and compaction. We added some soil amendments and added a whole lot of plantings. And an end result looks like that. So now the water comes in one side. There's a lot of groundwater recharge that occurs. The plants serve as filters, and we made minor modifications to the outlet structure to hold the water there a little bit longer, so there's more filtering action. But I think this was a pretty successful project. On that Moses Mills Drive, we found there was one one storm inlet that actually didn't lead to that basin. It discharged right to a stream nearby. And so we didn't want to leave that one unaddressed. So what we did in this case was we notched the curb on either side of this inlet, and we constructed a bioretention trench on either side. And essentially what happens now, the water runs down the curb, it runs into this infiltration trench. There's plantings in this trench with an underdrain. So that water is infiltrated. It ends up, goes into the underdrain and ends up right in the pipe it would have went in otherwise. In bigger storm events, when this thing overflows, the water will back up into the street and go right down to storm grate where it would have gone to begin with. But what we've done is effectively captured that first flush of runoff, which usually carries the highest amount of pollutants. We did some work with Lakewood Township at Lake Carasalgo Park. Around Lake Carasalgo and the adjoining park, there are dozens of stormwater outfalls that go right from the, stormwater inlets go right from the street right into directly into the lake or the river. And what we did was something similar to that second piece of Moses Mills. We constructed rain gardens, and this is a before and after. Again, before and after, and the mechanism is the same. Basically, the water is filtered by these plantings before it's discharged to the stream. We had an opportunity to work with Federal Realty Investment Trust at Brick Plaza. We wanted to look at commercial plaza and demonstrate some of the things that can be done there. One of the things we did was we took these raised traffic islands and flipped them upside down and turned them into rain gardens. Basically, we just excavated them, notched the curb, and now they serve as a sink for stormwater. And, again, the principle is the same: groundwater recharge, filtration. There were other things that were done at Brick Plaza. During their renovations, they added a bunch of porous pavement to areas where they could, where the water actually sinks right through the pavement, where there's not a lot of heavy traffic load. Federal Realty was, they kind of ran with this project when we were done with it. They really liked the results. And you can see they've installed more rain gardens all over the place. And you can see they are aesthetically, they look great. So not only are they improving water quality, but they look good too for people or the shoppers and customers that come there. We're not the only ones doing this kind of work. The American Littoral Society and Barnegat Partnership did some work at Ocean County Park. At the park, they installed some tree filter boxes. In these tree filter boxes, kind of the same principle. The water enters, it goes through the growing medium for the trees, and it's filtered and recharges into the ground. There was some stream bank restoration. There were some living shorelines, and they actually installed a floating wetland island. And the whole point of that island is it's a floating wetland. It sits on pontoons, and it's planted, and its purpose is to absorb nutrients, and that's still out there. Georgian Core University did some work on subsurface gravel wetlands. It's a type of stormwater best management practice that is particularly effective at removing nitrogen. So they installed 4 of these in conjunction with the Rutgers Cooperative Extension, and they had the students involved in testing them and whatnot, and they're still in existence over there. The Rutgers Cooperative Extension just this past summer did a project with Jackson Township, and it's similar to our Moses Mills Basin. You can see a before and after picture. They took a traditional detention basin and again turned it into a bioretention basin. So now where you had no water quality improvement, there is some. With the funding they had available, they actually were able to complete a design for another project at a nearby park called Woodland Park. There's a parking area where the runoff runs right into the river. So they have a design shovel-ready to basically filter that stormwater as it runs off the parking lot before it hits the North Branch Matitaconk River. So, getting away from stormwater now, there are other measures that are important. High-density septic areas are problematic, particularly for nitrogen. And there were some high-density septic areas in the Matitaconk watershed that were identified in the plan. Howell Township spearheaded a project to address one of these problematic areas in its jurisdiction and extend sewer service. And I understand that particular area was problematic. There were a lot of failing septic systems. So this is another type of project that will definitely improve water quality. Education outreach, that's a huge component of the watershed plan. I think it's probably the most important component of the watershed plan. Basically engaging the community and building awareness and stewardship for local water resources. We actually have a person dedicated almost full-time to going out and talking to students and civic groups, attending, putting on workshops, attending, different functions with exhibits, and to really engaging the community to discuss primarily non-point source pollution, stormwater management, and water conservation. And for those who are interested, that link there, www.matitaconkriver.org, is the link where you could get to the watershed plan if you're interested in seeing it in more detail. Water quality monitoring was actually really critical too. We have a database that goes back to 1998. It's probably slightly after. That's the data we find are very reliable. It's been QA'd. It's been looked at and examined for water quality. That data and the database was really important as we put together the watershed plan. We had some data to look at. We could look at a baseline, and it helped us not only decide or figure out what the status was, but where we need to go later. And it actually helps us as we continue to collect data to evaluate how we're doing in terms of plan implementation. Are we really seeing benefits? We have a state certified lab on site, which makes it easier for us in particular to collect the amount of data that we do. And we do submit our data regularly to DEP, so it's accessible to the public for different types of projects. Other types of plan implementation strategies that are relevant to nitrogen is open space preservation. Some of these we heard about earlier. Protection and restoration of riparian areas. Those are the areas that are located directly along the stream banks. That picture on the bottom left, that's not what you want to see when you see a stream. It's basically mowed to the edge. We want to see a nice, wooded or at least an area of vegetation along there to serve as a buffer, a filtering buffer. Agricultural best management practices, basically keeping agricultural activities from affecting nearby water resources. Lake management is an important strategy, looking at lakes and maintaining healthy water quality within the lakes, and water conservation, both indoor and outdoor. And when I say outdoor, I'm really talking about landscaping, irrigation. Those are all important strategies and actions. So, right now, Barnegat Utility is working on another grant-funded project with DEP. In that project, we're looking at tracking the sources of fecal coliform in the North Branch Matitaconk River, addressing that fecal TMDL I mentioned earlier. We're doing some additional detention basin retrofits with Howell Township, and we're working with Lakewood Township to install some of those smaller green stormwater infrastructure measures in downtown Lakewood. And we're also looking at some sort of end-of-pipe treatment, or the feasibility of some sort of end-of-pipe treatment at the largest outfall in the watershed, which I could probably almost stand up in. It's an enormous discharge pipe into the North Branch. But in the end, the various watershed initiatives we've talked about that are already underway and are continuing will help reduce nitrogen nutrient loading and help address the new TMDL. Barnegat Utilities and its partners are leveraging funding sources to get these projects done. And we are continually learning more cost-effective ways to do this. So basically, as we get funding, to make that stretch that funding and make it go a little further. And I just wanted to close and say, we're really fortunate to be here in the Barnegat Bay region. We have excellent resources and committed stakeholders and partners to support watershed protection. So I think we are in a really good place. So there's my contact information. I'd be happy to answer any questions anyone might have. We're good? All right, thank you.
Been some great themes today, and hopefully it set the stage. I'm going to have to fly through this, but everybody's done such a good job covering so much material. Hopefully this will all go smoothly. In 2017, the Barnegat Bay Partnership with DEP and many of the organizations in this room started the planning of its comprehensive conservation and management plan. And this is the themes. This is the first paragraph in that document in the water quality section, with no edits. And basically, I think you've heard all of this message repeated here today, so I'm not going to go through it. But then we are a water quality program. We're funded by EPA and established by a small portion of the Clean Water Act. And so it should be no surprise to anyone that reducing nutrient, contaminant, debris, et cetera, should be a primary action of our program. And so this is. And so all of the work today is consistent with the larger, bigger picture plans that were put together and set in motion by partners years ago. And that brings us to the watershed management plan for the Toms River. The goals and objectives that were identified by a very, very large stakeholder group with diverse representation are identified in black, red, and blue. I'm going to run through just a few of these things today. Rob and the folks in the Matitaconk have done a great job. Their plan was approved in 2013, somewhere around there. So they've been working for more than a decade. This plan is still under review and hopefully will be rolled out to stakeholders within the next couple of months. The biggest issue we all face, is change to our watershed. This is very quick explanation. This is the Toms River watershed. You can recognize the Sunken Branch, Davenport, Wrangell Brook, Jakes, et cetera. This photo is an aerial photo from 1950. Basically, the only thing living in this area were chickens probably at that point in time. This is that same area in 2010. I'm going to pick that one small area. That's that area in 1950. That was the version in 2010. So there's been tremendous land use and development in the watershed, and these are the problems that we're having to deal with in establishment of these watershed plans. And as Rob very eloquently went through the different steps in the EPA planning process, one of the first things you need to do is to address known problems. And he had a nice list. This is a little more of a graphical presentation. I don't want to go through all of these. We're focused mostly on the pathogen, nutrient, and DO issues here. But there are a number of them throughout the Toms River subwatershed, and they're in some surprising places. We attribute nitrogen loading and runoff from the developed parts of the watershed, and here you can see some of the worst problems we actually have in the upper headland areas of the watershed. So there's some surprising findings that have come out of this, and these are the problems that we're going to have to address as we move forward. Now, one of the first things we did in taking on this plan was basically just get out and look around the plan, look around the watershed, and just with Matitaconk, riparian zone protection enhancement is a priority throughout the watershed. The two photos on the upper section show what a stream looks like in good condition. And then we have very different perspectives on the bottom. Although the homeowners on the bottom left might like that nice, neat channeled view they have, this presents a variety of water quality and other problems. And the one on the right actually shows the stormwater system being overwhelmed. You can see the corrugated pipe that has mostly been obliterated and lots of sand that's run off into the system. So this is a problem essentially throughout the development parts of this watershed. What are we going to do about it? One of the things that we've already suggested and incorporated into the plan is a restoration of one of these stream riparian corridors. You can see this is Southern Branch I just presented in that first photo. We actually have developed a tentative draft restoration plan that would change that habitat and increase the width of those buffers and produce a very different stream corridor than we have now. This is one of the more expensive projects in this watershed. It's not yet been approved by the stakeholders, but this is something that we hope to move forward with the development of the plan for the Toms River watershed. Education is a big thing. Everybody's mentioned the fertilizer law. The soil health law is another piece of landmark New Jersey legislation. Former director of the Ocean County Soil Conservation Director was fond of saying, don't treat your soil like dirt. What we see here in those two figures is that soils throughout much of the watershed have a density close to that of concrete. And when you have a density that high, very, very little water gets back into the ground. So one of the things that we're emphasizing throughout the watershed, and as is supported by the Soil Restoration Act, is increasing pervious cover throughout the watershed. And we already have a program that's been working very hard for a number of years with the DEP and other support, a Jersey Friendly Yards program, which promotes establishment of native plants and methods to produce pervious cover. So these are efforts that are going to continue to be a focus throughout the watershed. As Rob mentioned, basin restoration is a big thing. In this particular subwatershed, the Toms River subwatershed, there's something like 850 stormwater basins. We've surveyed almost all of these in some way, shape, or form, and we've identified a subset of these that we believe should be restored. We've already seen pictures of low flow channels, et cetera, and before and after figures, but this is going to continue to be an important part of our effort. And as in other areas, we do have some septic and sewerage issues. This is a map of all of the existing septic systems. You can see the upper Toms River is lined with septic systems. There's a huge concentration of them around Pine Lake. So we've got a lot of work to do and can address significant loads, not only of nitrogen, but also of phosphorus if we were to take these on. One of the approaches we've tried to emphasize throughout is a preferred method called a treatment train approach. This is an example we're including in our proposed plan down closer to the bay. And there's no single thing. This basically involves stacking up a number of different kinds of processes, methods, and approaches to do different kinds of things, not only to capture stormwater, but also to provide some opportunities for it to be processed before it discharges, in this case, almost directly to the bay. As many of you know, the last couple of years, there's been a lot of federal funding, bill funding that's been distributed through a variety of means. We're one of those means. We've received approximately $1 million and will be receiving about $1 million annually for the next 3 or 4 years. One of the conditions on our spending these funds is that at least 40% of those address problems in overburdened communities. And you might think that there's not much opportunity in Ocean County for, that we have that many overburdened communities, but essentially half the municipalities in Ocean County do have one or more census blocks where there are opportunities for us to spend our funds. And we're actually excited. We're going to release a GFO, which is our equivalent of an RFP, to promote stormwater projects and improvements in these overburdened communities. And when will that come out, Andrew? Sometime in the late winter, midwinter? Okay, so here's an opportunity for funding to continue the work on these activities. And as Rob said very eloquently, education is an important component of these activities. We're delighted to have so many partners here today and so many partners online to work with us. Education is a really important tool and opportunity for all of us that we hope you'll join with us in doing. And then lastly, or next to last, we do have to keep in mind that conditions are changing, climate's changing, the weather is changing, and we need to keep that in consideration. And lastly, with regard to where we're going with all this, the TMDL is an important tool to get to a lot of things. But in addition to just improving the water quality itself, it also impacts a lot of other things that are important to us, including most of the things on this list. So we hope you'll all join us in that effort, and I thank you all for your attention.
Thanks, Dr. Hales. I'm not a scientist in any way, shape, or form, as you know. First of all, I want to laud Brick Township for the work they've done. That's a tremendous job. But the question I have is, I don't know if it's answerable or not answerable. As much work as Brick Township has done, there are other towns, and we all share Barnegat Bay. It belongs to all of us, and what we do affects Barnegat Bay. My thought is that the county, if they're able to, come up with a set of criteria for continued development throughout the county, where despite what one town wants to do and what another town wants to do, they all could be held to a standard of making sure that the bay is protected, that all the watershed is protected. And I'm wondering if that is something possible, or would you know if law preempts a county from doing something like that?
Well, I'm not a land use or legal expert about land use law in New Jersey, but I think the common understanding is that land use is locally determined. The way the TMDL works, and correct me if I'm wrong, I'll start to answer that. The department hopes to achieve reductions in nutrient loading to the bay, in part through the MS4 program. And that's a dynamic program. So with the continuing monitoring in place, there'll be a periodic assessment as to the progress we're making. And what I suspect is likely to happen, as has happened elsewhere, is that those rules change and become increasingly rigorous, for lack of a better word, but to address the issues and the problems that occur. And, you know, even with these planning documents, you might think that a watershed plan for the Toms River Basin, you could assess everything. You know, in our assessments, we looked at several hundred sites, and in some cases, we can narrow down a problem to a certain geographic area, but you might still need more information to figure out exactly what to do. So this is an iterative process. You know, we got into this mess with development over a 50-plus year problem. I hope it doesn't take 50 years to solve it, but it's not going to be achieved overnight, and it's important that everybody here be invested in that effort. So that's the most important thing, and that's why we all think education is so important to this effort. Thank you.
We did get one question in the chat asking if today's slides will be available.
Yes, this is being taped, recorded, et cetera, and we have all presentations so we can make them available.
Thank you.
Thank you.
Yes, today's presentation has been recorded, and the individual presentations will be posted. We'll send out a follow-up email to everybody that registered here in person and/or online. We'll send out an email advising you where the location of that information is so you can have it back for reference. And before I close out, is there any additional questions? Okay. We very much appreciate all the comments and everybody's input that we received today. You've given us a lot to think about. Our second session, we're going to delve into the science that serves as the basis for this nitrogen water quality target and the TMDL reductions. We anticipate having that sometime in the new year. We're going to go back, strategize, think about the questions that you asked us today, what additional information we need to put together, and then we'll have a follow-up session where we'll delve into the nitty-gritty of the science and hopefully answer any questions that you have at that time. Then for our third session, you heard about some of the ongoing initiatives in the Bay. We want to incorporate this into our TMDL implementation plan. We want to continue this dialogue with everyone at the third session. So we'll focus on implementation of projects, initiatives, and best management practices, again, through the MS4 program, also voluntary efforts, and hear more about the Metedeconk, Toms River, and other watershed-based plans that are and will be coming to fruition in the new year as well. This is a lot of information, so we wanted to give you time to digest this. When the department comes out with the TMDL, we will do so later on in the calendar year 2024, but we wanted everybody in the watershed to come from a place of comfort. We wanted everyone to understand the science behind the standard, the TMDL. We wanted folks to feel comfortable with the implementation part of the TMDL. So that's why we're having these three sessions before we formally propose the TMDL, again, at that time, for formal public comment. So during this time period leading up to that, your feedback, your comments, your input, that is everything that we can take into consideration so that when we do propose the document, we hope it's to your satisfaction and that at that time, the comments will be minimal and or anything would have been anticipated ahead of time and addressed in the TMDL document. So we feel it's really, really important to have the stakeholdering process. We appreciate everybody that was here, stayed on the line for 3 hours, and those of you that came in person. So the department will be here for a little while longer. Again, we thank all the stakeholders that helped put this session together today, and we look forward to seeing you in the new year. Thank you.